Welcome, everybody, to another part of our series of magnetic innovation and technology. I'm here again with Andy Robinson, who is the business development manager for SM Magnetics. Andy's expertise is in the medical industry. He works a lot with medical customers, academic customers, high-tech customers, and a lot of research institutions. So, Andy, welcome.
Thank you.
Welcome.
Thank you for having me back.
Great. It's good to have you back. Uh, Today, Andy, we're going to be talking about coatings on magnets, coatings and platings on magnets, and specifically those coatings and platings that are most commonly used in the medical industry. And during the next 6 segments, what we would like to do is focus on some general questions, first of all, about coatings. Secondly, gold, and get you to talk about the pros and cons of gold. And then we'll go into Parylene, and then rhodium, and then titanium nitride. And then finally, we're going to end with PTFE, which some folks know those through a different name, a brand name called Teflon. But Andy, we're going to have you speak to the 2 different kinds of PTFE, spray on, and then the molded version.
Okay.
So real quickly, for those viewing the video, we have an added function to the video now. You'll notice a scroll bar underneath. That scroll bar has sections to it, and at any time you can just click on that scroll bar to go to a different section if you're just more interested in one of the coatings that we will talk about in this video. So Andy, I'm excited to have you here. Let's get started with some general questions about magnets and coatings specifically in the medical industry.
Okay, great.
We're here with Andy Robinson, and we're talking about magnets and the medical industry, and specifically the coatings on those magnets that are commonly used in the medical industry. Andy, I'd like to start with some general questions first, and then we'll go into the very specific coatings.
Okay.
First question out of the chute, why does a magnet need to be coated?
Well, usually when we coat a magnet, we're going to coat neodymium. And that's the one we're really going to focus on here. And the reason why is because neodymium can oxidize very quickly. And so the magnet will rust. That's not good in any situation, but especially for a medical application.
Okay. And I understand that the magnets themselves need to have some sort of edge break on them prior to a coating. Now, why is that?
Well, the reason why is because if we don't have the edge breaks, we have a sharp edge, corner, whatever that is. And when it goes through the plating process, the plating is actually going to stick off of it, almost like a flake that you'll see. And that's very brittle. If that breaks off, it's going to take a piece of the magnet with it. And we've also exposed the magnet material to oxygen. So we do the edge breaks, the tumbling, just to get a small radius.
And approximately what is the tolerance on those edge breaks, Andy?
That is actually going to be dependent on several factors. Usually it's going to be the chamfer of the radius, product dimensions, that will have an effect on it. And then of course the product structure itself. If we're looking at very general cases, we're probably going to follow an ISO 2768 standard. But otherwise we may look to the customer to specify that.
Okay. And I guess the last question around the edge breaks are, do the edge breaks actually have an effect on the magnetic field?
Good question. And the answer is yes, they do. The reason is you're losing material. So you're going to lose some strength to the magnet. Usually it's pretty negligible, but if we're dealing with micromagnets, it's actually going to count for something greater than what you would actually think it would.
Okay. And Andy, to follow on this theme of edge breaks, how about if there's a hole in the magnet? What issues need to be considered from a coating purpose if there's a hole in the magnet?
Great question. The size of the hole, really, what is that diameter? Because we need to understand that, especially for tumbling. We need to make sure the tumbling media is correct so that it can actually break those edges for the hole. And then again, looking at the hole diameter, can the plating go all the way through and coat the inside of that hole?
Okay. And from a coating standpoint, Andy, how do you measure thickness of a coating?
We will do metallographic testing. So we will take a magnet, cut it, and then we'll examine that testing, and we'll be able to see each layer and be able to tell how thick each layer is.
And do you control the thickness through the process, or how do you control it?
It is through the process. It is difficult to control, usually because they're done in baths, and so some magnets are just maybe a little bit thicker than others, but we do this based on time, and time is usually the biggest factor to really help us get as uniform as we can just across the entire lot.
Okay, Andy, we're going to talk more about the exact thickness on each of the with each of the different coatings as we hit those coatings. So I'll ask you that question. But let's move on to our first coating, and that is gold. So let's
Okay.
move on to gold.
All right.
We're here with Andy Robinson. Andy, the first plating that we're going to talk about is gold plating. And I know that gold is very prominent in the medical industry, but can you start by telling us the approximate thickness of a gold plated magnet?
Sure. The standard thickness is zero point 0.1 micron, and that's very thin, but it's just because that's just gold. The thickest we can go is 1 micron, and with each step up, or with each point X micron you go, it also carries a higher cost.
Okay. And I'm assuming you have an example of a gold magnet that you could show on the screen while we're talking through this.
Yes, we do have some gold-plated magnets, and we'll show them here as well.
Okay.
So yeah, as you can see, these are some small, some oblong disc shapes, not quite an oval, but sort of like that. And then here's also some ring magnets that we've got that are also gold-plated.
Andy, if you could tell us why gold is such a good plating for the medical industry.
Well, I mean, nothing, you can't really penetrate it, honestly. We've been putting it in human bodies for a few hundred years. We've had some very good success with that, and that's why it's still used today. And that's why I'll use this example with gold. You go to the bottom of an ocean, and you could find gold coins that have been there for, a few hundred years, and they look brand new.
Mhm. So, from a application standpoint, is that where you mainly see gold in the body, or where do you see it?
Usually, yes, I will see it in the body.
Okay. And do you have some applications that you would suggest for gold plating?
If the magnet is going to be exposed inside of the body, whether it's a partial exposure or full exposure, I would strongly recommend gold coating.
Okay. Andy, quick list: pros, cons of gold plating.
Pros, again, gold. It's a fantastic coating. It gives you some complete coverage of the magnet. Uh, I would recommend to do that. Go a little bit thicker, maybe zero point 0.3 to zero point 0.5 microns. That helps to keep the costs down a little bit. But again, I think it's a fantastic coating. FDA is usually very happy with that. Cons, it can be a little pricey, I will say. The other con is it's very thin. So it just, again, the thickest it can go is 1 micron, which, we have the success there, but some can look at that as a con.
So, Andy, you talk about the thicknesses going from 0.1 to 0.3 to 0.5, whatever that thickness may be that the customer wants. Does the gold have a specific lifespan to it based upon the thickness of it, or is it just a general lifespan of gold, or does it have a forever lifespan?
Well, really, it's application dependent. It truly is. So I can't really give an answer, and also it will be thickness dependent. If you are in the very thinnest part at zero point 0.1 microns, then you could very well look at some a very small hole in the plating, just because you don't have that complete coverage, and that can lead to, if you have some fluids, even saline, it could lead to just penetration through the magnet and get all the way through the nickel plating and eat away at the neodymium.
So, Andy, I'm going to take the next. I'm going to combine two questions into one here, and that is, how does gold stand up to, say, external operations like sterilization or an autoclave function? And the second part of that, is there a maximum temperature spec for gold?
So autoclaving, typically I see that range from 90 to 120 degrees Celsius. Gold plating is fine. It does not, its melting point is greater than 1000 degrees Celsius. So it's okay. In terms of sterilization, haven't seen any negative effects from it. Again, you just want to make sure you have the right thickness so that it can withstand sterilization if it's going to be in some fluids for sterilizing.
Okay. Last question on the gold is, does a gold plating actually have any effect on the magnetic field itself?
Different metals do have an effect on the magnetic field, but it's so little that in many cases it's just not measurable.
Okay. Okay. Andy, let's move on to Parylene and talk about Parylene next.
Okay.
We're here with Andy Robinson. Andy, we're going to move into Parylene coatings and discuss a little bit about Parylene coatings. To start this section off, do you have examples of some Parylene coatings that you can show?
Yes, I actually have a couple of them, and they're very small. The first one is something that we stock for one of our sister companies, and you can see it's a disc magnet, and it has just not a pretty appearance to it, so it's kind of ugly. But that's the Parylene. The other one, it may look a little familiar. We just showed it in the gold coating. This is actually gold with Parylene on top of it.
So looking at these, Andy, Parylene is very transparent.
It 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 is.
Yeah.
Yes, and
Okay.
Parylene actually can be plated directly on the neodymium magnet.
Oh, okay. So it has it has some multiple options to it. It's not just doesn't have to go direct onto the magnet. It can go
Right.
onto another coating.
Correct. It can go on to another coating, which is actually always recommended. But for some purposes, customer may not want that, and so they may want a bare magnet coated only with Parylene.
Okay. And what is the approximate thickness of Parylene?
We can go anywhere from 1 micron all the way to 70 microns.
Oh, all the way to 70. That's a very large thing. So, and why is Parylene just like gold? Why is Parylene such a good option in for medical?
Well, it is FDA approved, and there are many types of Parylene. The most common type is Parylene C, and that's what we coat with just for standard stock parts. But one of the other ones that we have done is Parylene DIXC. There's some other ones, for example, Parylene HT, and each Parylene coating does have an operating temperature, and it's not the same across the board.
Okay, okay. I'm going to get into operating temperature in a second,
Sure.
but for the Parylene magnets that you have worked with your customers on, is the main application external of the body, internal of the body? What do you see as the main application for a Parylene coated magnet?
Typically, it's going to be internal. However, we do see some uses outside of the body, and that's typically going to be in labs. Maybe if they're taking blood samples or really just any kind of samples like that, they may use Parylene.
Okay, okay. And just like gold, pros and cons? Quick question, pros and cons.
Pros, it is FDA approved. Um, and it does have its uses. It does. It can withstand some different things as long as it's handled with care. I can't stress that enough for Parylene. The cons is it can have a higher failure rate just because it can come off easily if it's very thin. Cons, it's very expensive. So that will really take up your cost a lot. And again, it's the same rule. If the thicker you go, the more expensive it's going to be.
Okay, so Andy, is it safe to say that anybody that uses Parylene, handling is extremely important?
I would say so, yes.
Okay, and is there a lifespan for Parylene?
Again, this is going to be a common theme that you will find, and that is it's very application dependent.
Okay, and gold, we talked about gold being used in applications where there's sterilization and autoclaving.
Mhm.
Does Parylene also function in those two environments?
It They can. I'm not 100% sure exactly how they will react. For example, normally Parylene has a maximum operating temperature of 120 degrees Celsius. So, as I mentioned earlier, you know, that's the max range I'll see for autoclaving is 120 Celsius. So, we're already there. So we may look at a different type of Parylene that can withstand that. For example, Parylene HT can go up to 350 degrees Celsius.
Okay. And Andy, as you work with designers in the medical world, do you have advice to give them on some considerations when using Parylene?
Think about it
Okay.
long and hard. I mean, really think about it. If it is necessary, then use it, absolutely. But really take into consideration the environment that it's operating in. What types of effects can you see on the Parylene? So do some extensive testing with that Parylene.
And are there going to be any effects on the magnetic field with a Parylene coating?
I don't believe so, simply because Parylene is not metallic usually, like gold is, or titanium nitride, or rhodium, even the nickel. So if your magnet has the undercoating of nickel, copper, nickel, you will see the effects.
Okay. Okay. Sounds good. All right, Andy, we're going to move on to rhodium next.
Okay.
We're here with Andy Robinson. Andy, in this section, we're going to talk about rhodium plating. And just like we've started the past sections, do you have examples that you can show of some rhodium?
Yes, I do actually. So if you'll see, these are some rhodium plated magnets. They look very similar to nickel plating. That's just the image itself. In actuality, it's going to be a little bit brighter than nickel, but that's rhodium.
And what's the thickness on a rhodium plated magnet?
Uh, Rhodium thickness, oh boy, it usually we're going to start around 1 micron, maybe a little less than 1 micron, actually, similar to gold. The difference is rhodium, you can go a lot thicker than you can with gold, but the biggest drawback is cost.
Okay, rhodium is a very expensive material.
Very expensive.
Okay, so if you are going to use rhodium, then I guess your suggestion would be to stay as thin as possible. Is that what I hear?
You have to find the balance.
Okay, okay.
Yes.
Now, most people will know rhodium because it's used in jewelry applications, but in our situation, we're talking about rhodium for medical applications.
Mhm.
Why is rhodium so good for a medical application?
Well, it's a fantastic coating. It works very well in many medical applications. It can withstand the different fluids. Again, it can go inside the body. We're currently working on an application where they're using it inside the body, and specifically, it will be exposed to blood.
Okay, so is that coating pretty hard and impenetrable? Is that why?
Yeah, it's pretty hard coating. It really is. I'm not exactly sure of what the shore hardness is of rhodium, but it's a good coating.
Okay, so pros and cons again. You know, the quick question: pros and cons of rhodium.
Yeah, well, again, it can go inside the body, so that's always a good thing. We can go thicker than gold, which is a great thing. It has a max operating temperature of pretty close to 2000 degrees Celsius. That's about its melting point. So, again, autoclaving is not an issue. The cons, again, it's going to be thin, just like gold. Uh, and the biggest con is cost. It's just very, very expensive.
Okay. Now, Andy, I know I've asked this question. It'll be my last question regarding rhodium, but I've asked it for the other things that we've talked about. But does rhodium have a lifespan, a limited or an extended? But let me ask it this way: Is when I ask this question, should I also be asking you, does it have a lifespan based upon its environment, its application, its all those things?
Yes, because that will be, yes, that again, that's the common theme you'll find, and it's is truly application dependent.
So if rhodium was used in an application that was truly meant for rhodium and it's not going to damage the code, could it last forever?
I would say so.
Okay. Okay. All right, great. Andy, we're going to move on. We're going to
Oh,
move on to the next one that I see coming up more and more in this world, and that's titanium nitride plating.
okay.
We're here with Andy Robinson. Andy, in this section, we're going to be talking about titanium nitride, which seems to be a coating that has gained in some popularity recently for some reason. However, to start the section off, just like all the other sections, do you have examples of some titanium nitride that you can show?
I do actually, and it's this very small disc magnet. Again, I think
Okay.
you're seeing a theme here with small magnets in these coatings.
Yes.
But as you can see, the titanium nitride, it's kind of a dirty gold color,
Yes.
if you will. That's about the best way I can describe it, but this is it.
Okay. And Andy, how thick does titanium nitride go on?
It ranges from about 3 to 6 microns.
3 to 6 microns. Okay.
Mhm.
And do you recommend this coating a lot of times, or what do you say to people that are designing with titanium nitride?
I actually don't recommend it.
Okay. And why is that?
The reason is it has multiple risk points for failure, and that has to do with the coating process.
Okay. So can you then describe a little bit about the pros and cons that you would see and you would talk to a designer about when it comes to titanium nitride?
So, the pro is, it can be used inside the body. So
Okay.
that's a good thing. But, that's a pro. Another pro is it is thicker than gold, thicker than rhodium, which is great. But the cons are it is expensive. And again, it's got multiple points of failure possibilities.
Okay. Are the points of failure in the coding process itself or possibly in the application later?
It, it would it could be a combination of both. It's definitely going to be in the process itself. So
Okay. Okay. And does titanium nitride, you mentioned it's a little bit thicker than gold, or it can be thicker than gold. So for that reason, does it have an effect on the magnetic field?
again, it is a metallic plating, so it is going to have an effect, but it's really hard to measure. It's hard to define what that effect is.
Okay, Andy, I know I keep asking you the question about the effect on a magnetic field, but to be fair, I should also be, I guess, clarifying that with, is there an air gap issue between the magnet and something else that could cause this effect?
Okay. No, not that I know of, or not
Okay,
that I've seen.
okay. So can titanium nitride stand up in, say, an autoclave application?
Oh, absolutely. It has a melting point that is close to 3,000 degrees Celsius.
Oh, okay. I think that's probably fair that it could stand up.
I think it can.
Okay. And then the last question I have here is long term. Again, if used correctly, what is the long term life of titanium nitride on a magnet?
It should be, again, it should be for as long as it needs to be for the life of the product itself, as long as A, it's used correctly, but then B, we come back to that risk factor. As long as that risk factor does not exist, then you should be fine.
Okay, okay, that sounds good. Okay, Andy, we're going to move on to our last coating, which is actually a dual topic because it's PTFE coatings, and the two kinds that we're going to be talking about are spray and molded.
Okay.
We're here with Andy Robinson. Andy, the last coating that we're going to talk about in this video is PTFE. Some people know it by its brand name by DuPont called Teflon, but I will reference it as PTFE throughout the conversation right now. To start, Andy, do you have some samples that you could show? And specifically, do you have first a sample of the spray PTFE that you could show, and then secondly, the molded PTFE?
Yeah, I have both. So the first one is the spray PTFE, and you'll notice it's black, and this is what it looks like, and it feels a little different than what you might actually think it would look like, but this is it.
What is the difference of the feel?
It's not as smooth as molded PTFE is, so it feels just a little bit rougher, not very much, but just a little bit.
So from the molded PTFE, do you have something that you can show us about the molded PTFE?
I do, and you can see this one is actually a bigger magnet. It's the biggest magnet we've shown so far, and this is what the molded PTFE looks like, and you can see it's white.
Okay, so Andy, I'm going to ask first about the spray PTFE because it looks like that's a much heavier thickness than what we've talked about previously.
Mhm.
So can you talk to the range of thickness on this spray PTFE?
Yeah, it's actually, I haven't worked a lot with it, just a little bit. So the range is actually a little bit greater than what we've been talking about, probably somewhere closer to, I'd say, even upwards of 25 microns or greater. Although Parylene is, we did talk about getting all the way up to 70 microns, which is very thick, but the spray PTFE can go pretty thick as well.
Okay. And then how about the molded? Molded looks like it's pretty beefy.
Molded PTFE is far more robust. It averages out to be about half a millimeter thick.
Half a millimeter thick. Okay.
Yes,
So you really have to take that into account when designing it sounds like.
you really do.
Okay. And so come specifically now to the medical industry, and I'm going to ask you to start on the spray PTFE, and why is that a good option in the medical industry?
PTFE in general is a good option for the medical industry for a variety of reasons. I mean, fun fact, PTFE is really the only thing a gecko cannot stick to. So, so I'm told. I haven't tested this yet, so I can't speak to it. But so it's got a lot of great applications, especially in the lab setting.
Okay. And so is that for both spray and both molded, or is there another reason why molded would be good in the medical industry?
Yeah, that would be for both. But another reason for molded in the medical industry is, especially if it's outside of the body, you don't want to put that in the body. That would just be very big. But outside of the body, it really protects the magnet itself. And so if the user drops it, it's not going to break. And if by some chance the magnet does crack, it's contained within the PTFE.
Okay. So Andy, I noticed the two examples that you showed, the molded PTFE magnet was bigger, as you mentioned, it was the biggest magnet. Are there size limitations for the molded PTFE on the
Absolutely.
magnet? I'm sorry, on the magnet. Are there? Okay.
Yes. Well, yes, there are. And it has to do with a few factors. Number one, the thickness, again, is half a millimeter. So, to your point, like you said earlier, you have to really take that into consideration when designing with molded PTFE. So you have to look at your finished dimensions, what you want those to be compared to what you are requiring from the magnet, because we're adding a lot of thickness in between the magnet and whatever it's trying to either attract to, or if it's a sensor, it's trying to trigger. So you really have to take that into consideration.
Yeah. Is it fair to say that for spray PTFE, you see that more of an in-body, and for molded, you see that more as an out-of-body medical application use?
I would actually say I haven't seen either. I've actually seen more requests for molded PTFE to go in the body. Uh,
Okay. Okay.
and I always steer them away from that. And it's usually because the magnet is too small.
Okay, the magnet's too small. So again, it comes back to the limitation of the PTFE and needing a bigger magnet than a spray PTFE or gold or Parylene or something like that. Okay.
That's correct.
So, the speed round again, pros and cons of each. Start with spray and tell us the pros and cons of the spray PTFE.
Spray, it's got good coverage. Again, you won't really see the risks in terms of like you would with Parylene or with titanium nitride. So it's got very good coverage on that. And it is also usually food grade. So that is a very good benefit that you have. Cons, it is pricey. And a big con is it can scratch off very easily. Even if you were to take a paper clip, you could just start scratching away and it would reveal the magnet beneath.
So for you, knowing the handling issues, is that important for you to know that?
It is. It is. And if a customer cannot or will not share that, that's okay. We will just still, let the customer know that they need to exercise extreme caution when handling these magnets just because it can scratch off easily. So to make sure if there was any kind of a press fit involved or any instrumentation that's used with the magnets, just to make sure it's not a sharp object.
Okay, okay. And Andy, now I'm going to move you over to the molded PTFE. Pros and cons of that.
Pros, again, a fantastic coating, very robust, really protects the magnet, very slick surface. So again, in a lab setting when you're dealing with multiple types of fluids, chemicals, uh, molded PTFE is a great option. The downside is you have a very long lead time with molded PTFE, usually around 60 days. It is very expensive. There will be a tooling charge. Um, and I go back to, while this is a pro, it's also a con in that it's a very slick surface. So if you're looking to use it in a holding application, just make sure you've got enough power, because the shear force is going to be, it's just going to pull that magnet right down.
Okay. Okay. So can both the spray and the molded stand up to sterilization, autoclaving?
That's a very good question. They should be able to, but again, that's going to be very dependent. I'm not 100% sure on the spray PTFE. I don't work with it very much in those types of settings. We just don't get enough requests. But in terms of fluid sterilization, the PTFE should be fine.
Okay. So Andy, one of the problems or issues that we see in the magnetics industry is things jumping to a magnet as opposed to a magnet jumping to something.
Mm-hmm.
So in the world of medical, you mentioned things like scrapes and scratches on the PTFE coating. Is that those scrapes and scratches, other than handling, is
Mm-hmm.
that a concern for a designer, like its environment that it's going to be in and things jumping towards it? Is that one of the things you talk to them about?
I would definitely talk to any designer in any industry about that. If you're working with magnets, be aware of the environment that they're going to be around. Uh, Even if they're just sitting on your desk for a few minutes while you're working on your design, be careful. Again, anything, a paper clip can scratch off the molded PTFE. So just little things that can cause damage like that. You just have to be careful.
And Andy, final question for this, but sounds like these are maybe a little bit thicker. So again, an effect on the magnetic field or not effect on the magnetic field?
It's going to have an effect on the magnetic field, but not from a standpoint of metal.
Okay.
And really what it is because of the thickness, we're increasing that air gap between the magnet itself and whatever it's trying to reach.
Okay. Okay. Very good. Well, Andy, I want to thank you. Thank you for spending some time with us going over coatings in the medical industry. I really appreciate that. For those of you viewing this that would like to reach out to Andy, his contact information will be on the screen and will be up for a moment. But again, Andy, appreciate your time, appreciate your expertise. And
Well, thank you for having me again.
thank you very much.
All right.